Okay, so in this video I'm going to have a look at projectiles, and in particular I'm going to have a look at maximum height and range of a projectile. We're going to have a look at these two equations here, one for maximum height, one for range. Now in this particular scenario here, we're going to assume that there's no air, so there won't be any air resistance, there won't be any drag. So we should end up with some kind of a nice symmetrical curve like this. So the object will start here and finish here. We're going to look at range out as far as here and maximum height here, roughly about here. So we're going to assume that the projectile has an initial velocity u, meters per second, and it's fired at an angle alpha to the horizontal. Now the first thing we're going to do is just look at our Suvat equations and look at the velocity in the x direction, the distance in the x direction, velocity in the y, and distance in the y directions. So let's write those formula down anyway. So we're going to use v is equal to u plus at for the velocity. So we have the velocity in the x direction is going to be u in the x direction plus at. Now there's no acceleration in the x direction, there's no gravitational force in the x direction, so really this part of the equation will become zero. So this is our velocity in the x direction. Now if we take our initial velocity here as being u meters per second, and we just split that up into horizontal and vertical components. This is our alpha here, our angle. So this here will be u cos alpha in the I direction, and this will be u sine alpha in the j direction. So our velocity in the x direction then is going to be u cos alpha. Okay, so let's look at the next equation. Then we're going to look at the distance in the x direction. So the distance in the x direction, we're going to use s is equal to ut plus half at squared. So our distance then in the x direction will be u in the x direction times t. Again, there's no gravity in the x direction, no gravitational force in the x direction, so this part of the equation here, this part of the formula here will become zero. So our distance in the x direction expression then will be u cos alpha, that's our initial velocity in the x direction, times time. Okay, so let's look at the next two then. We're going to look at the velocity in the y direction. Again, what we're going to do here is use v is equal to u plus at, which we've written over here. So our velocity then in the y direction is going to be equal to the initial velocity in the y direction minus gt. So this will be our initial velocity in the y direction is going to be u sine alpha, and then it's going to be minus gt. So our distance then in the y direction is s is equal to ut, so it's going to be u in the y direction times t minus a half gt squared. Velocity in the y direction again is u sine alpha, that's times time minus a half gt squared. So these are our four formula that we're going to use in this video. We'll start with looking at the greatest height above the horizontal, the maximum height. So let's do that first. So at the greatest height, the velocity in the y direction is going to be equal to 0. The acceleration is just minus g meters per second squared, and our initial velocity in the y direction is equal to u sine alpha meters per second. And we're going to say that the distance in the y direction, we're going to just call it h, large h here, and that's in meters. The formula we're going to use to develop this particular equation is v squared is equal to u squared plus 2as, and this is in the y direction as well. This is what we're going to use. So that would just give us then, let's see, we have the velocity we know at the maximum height is going to be 0. So we'll have 0 is equal to the initial velocity in the y direction is u sine alpha squared minus 2gh. So that will give us then minus u squared sine squared alpha is equal to minus 2gh, or just simply h is equal to u squared sine squared alpha over 2g. And that's really it. That's the first equation that we decided to derive. Okay, so let's look at the next one. So what we're going to do here is find the distance in the x direction when the distance in the y direction is equal to 0. So we're going to find the distance in the x direction when the distance in the y direction is 0. So we're going to look at the distance in the y direction formula that we developed at the beginning, and that was s in the y direction is equal to u sine alpha times t minus a half gt squared. So we know that the distance in the y direction, or we want the distance in the y direction to be 0, so let's just change this. So we've got 0 is equal to u sine alpha times t minus a half gt squared. Let's just factorize out the t. So that'll give us t times u sine alpha minus a half gt. So we'll end up with t is equal to 0, or u sine alpha minus a half gt equal to 0. So if we just manipulate this, I'm going to bring this over here, multiply everything by 2 and divide by the g. What I'll get then is just t is equal to u sine alpha times 2 divided by g. So this is going to give us the time it takes for the distance in the y direction to be equal to 0. So this is really just this time, the time it takes to get to here. We found that the time was equal to 0, and the time was equal to 2u sine alpha over g, so that's when it reaches here. Okay, so let's use that then to develop our formula. So we know that the distance in the x direction, we developed this equation earlier, s of x, sx I should say, is equal to u cos alpha times t. We have our t now, so it's going to be u cos alpha times 2u sine alpha over g. So let's just manipulate this a little bit. We have, let's see, u times u is going to be u squared cos alpha sine alpha. And that's all over g. So we know from our tables that 2 sine alpha cos alpha is just going to be equal to sine 2 alpha. So I can change that. So we have u squared here, and then we've got sine 2 alpha. That's all over g. Now this is the distance in the x direction, so this is just our range then. Our range is just going to be equal to u squared sine 2 alpha over g. That's it. That's our second formula. So what I might do as well is just do a dimensional analysis on both of these. This is our first formula here. So let's see what we've got. We have u squared. Well, u is just going to be our initial velocity, so that's in meters per second, and we want to square that. Sine is just going to be a constant, so we're not going to worry about that. And g on the bottom here is meters per second squared. So let's see, if we just do at the top here, we get meters squared over second squared. We have a fraction on the bottom, so I'm just going to multiply its inverse, so that's second squared over meters. And you can see here that the second squared will cancel with the second squared here. The meters here will divide into one of these meters up here, and we just get meters. So you can see here that the height would be in meters, and we did get meters when we did our dimensional analysis. So let's do the same down here. This is range. So again, we should get meters again. So again, we have u squared, so that's meters per second, and we want to square that. Sine again is going to be a constant. On the bottom we've got meters per second squared. It's the same kind of thing again. We've got meters squared over second squared times second squared over meters. So this will cancel with this will cancel with one of these, and again we end up with meters. So, and we know our range has to be in meters, so that's fine. Okay, so what we can also do with this formula is just have a look at it to see if we can work out what the angle of projection would be to give us a maximum range. So if we take our or is equal to u squared sine 2 alpha over g, this fraction here would be maximized if sine 2 alpha was equal to 1. Remember, sine ranges from -1 to +1. So the maximum that sine 2 alpha could be would be 1. So we need sine 2 alpha to be equal to 1. That means sine inverse 1 is equal to 2 alpha. And we know that the sine of 90 degrees is going to give us 1. So that means our 2 alpha here is going to be 90 degrees. Or our alpha, our angle of projection, should be 45 degrees. So at 45 degrees we should get a maximum range. So our maximum, the maximum range will be when sine 2 alpha is equal to 1, or when we have just simply the initial velocity squared over g times 1. That will give us our maximum range. Okay, so that's it for this video.